People can see my screen, hopefully.
Yep.
Cool. Um, yeah, as Adam said before, I'm Afton. I'm a postdoc in the Programming Environments and Models group at NERSC. Um, and so for session two, well, back in, as you just heard from Adam in session one, he talked about how you can use containers and ways you can share containers and the container files. Um, so in this section, we're going to talk about how to make a container file and then how to build your container image from that file. So first, making the container file. Um, this is an overview of a lot of the basic commands that you would want for writing your own container file. This is not everything in the world of possibility, but this is a lot of the basics that you would want to get you started. Um, and so one of the things that we would say is the best practice is if you know how to get to the environment that you want to be able to have in your container to run, your application. If you have a bash script that would install everything that you need, if you have that to start with, that is a nice starting point for something to convert into a container file, to get the idea of like what all of the libraries that you want are, for instance, and like what you want your path to be and everything. If you can already do that on bare metal, then that is a good starting place to be able to write your container file from. Um, but yeah, so some of the commands that you will use, important first one is the from command. There were some lines of this in session one. You saw this big all capitals from all capitals is like all of the commands for the container files. So in this case, we are grabbing the Ubuntu 24.04. You definitely need to have some sort of operating system, but you can actually grab either a vanilla version of Ubuntu like this, or you can actually start with any container image that you want and that you might just want to add a couple things to. Um, and then also another command that we want is we might want to set up the working directory where we're going to be running our commands from. Another really useful thing for flexibility in your container files is to be able to use arguments. So in this example, like we're talking about a different version of the code, like maybe there's some library and you want to be able to load a couple different versions of it in a couple different images that you want that are very similar. This is something that'll be easy for you to just have a variable that you can quickly change in your container file. Um, and then the main thing in your container file that will actually run the commands, the type of commands that you would run in your bash script is this run command. Um, and when you're writing your container files, something useful to do is to actually put each of those like bash commands in a different line of the container file, but you can use the double ampersand to combine them into the same run command. But if you separate them out into different lines, then if when you go to build your container file, if you have any issues, you can more easily debug, and we'll talk about this later, but you can, comment out the lines where there are the problems if you actually have them on separate lines. Um, and when we're building a container file, you'll note this little orange dash Y. In this case, it would ask you, like, do you want to install, this file of this size? It'll ask you, a bunch of times. You want to, decrease the number of interactive things that you need to do when building. So that's like a useful little hint there. Um, we can set up environment variables using this, env command. So those are going to be environment variables that will be in your container. Like once you're running something in the container, it's in that environment. It doesn't change the environment that you are using in the environment in which you're building the container. It's not changing that environment. It's the environment inside of the container. And then copy command is useful for bringing in files that you have that you want to get inside of your container. It would be like doing CP in, anywhere in like your base, operating system. But in this case, you're bringing something from outside the container to be able to like build into the container. Um, and then as Adam talked about before, this entry point is the thing that, we will run whenever you run the container, this will run when it starts up. Um, and like I said, that's just sort of a few basics, but for more information, there are all of these links here. The NERSC documentation always has a bunch of useful things for running on NERSC and in general. We have a bunch of container files that you can use in the NERSC GitLab. And like I said, you can use any container, any base image that you want to start with when you're building your own container file. So you might want to use any of these as your image to start with and then add things on top of that for your own image. Um, and another helpful reference is the containers for HPC slides. Um, as Adam was saying, the because of OCI compliance, Docker and Podman HPC have a lot of things that should be, interchangeable. So you can actually just look at any documentation for Docker should help you with Podman HPC as well. And then a lot of people will use the NVIDIA container files if you're wanting to run, anything using GPUs. This is really helpful. So you can use those also as your base images from which to build your own container files. Um, and then so we have our container file. Now, how do we build a container? Um, on Perlmutter, you can only build containers using Podman HPC, but if you want to run with Shifter, you can also, build some other way. You can push to a registry and then pull with Shifter. You can build however you want, or you can build on Perlmutter with Podman HPC, push that to the registry, and then pull with Shifter. Um, so to build a container with Podman HPC, this is an actual valid two-line container file with this from line and the entry point line. Um, so this will start with our base operating system of vanilla Ubuntu 24.04. And then it just gives, the entry point initial command to run when starting the container. So all this will do is build a container in Ubuntu that will print no lulls here when we run it. And then to build it, a simple like one line command, use just podman hpc build. We're going to want to tag it with a name for the container, and then you'll also probably want to have a version for the container. So this one we're going to call no lulls 1.0 because lulls are the theme of this training. Um, and then you'll note like we have the period here. We're running this build in the current directory in this case. And in that case, you need your container file to be called container file. But if you want to have a container file with a different name or build it in some other location, if you use the flag -f and then you have your path and name of your container file, you can have a differently named container file and it can be in a different location than your current directory. Um, and as before, we can view our images using podman hpc images command. So after you build, you should be able to see it in your list of images. So like in this example, now we have this no lulls 1.0. And you'll see that the location is localhost, whereas it will also pull in this base image, the base Ubuntu 24.0.04 image, and you can see that one is located on Docker Hub. And then so you're running this on an HPC system. You're going to want to eventually run, presumably, on the compute nodes. And to do that, you actually need to get the image into Scratch. Now, as in part one, when we were pulling a container from somewhere else, this will automatically bring it to Scratch. But because in this case, anytime you're actually building your own container on one of the login nodes, you have to actually move it using the migrate command to migrate it into Scratch. So we just say migrate, which container we want to migrate. Um, and something to note is that the version that will be available on Scratch once you do this, um, it doesn't get automatically updated. If you were to make any changes and rebuild the container, you will have to re-migrate because these images are not linked together. You're just moving the current image when you do this. So every time you make a change, make sure you re-migrate if you want to actually reflect that change when you're running a job. So some helpful hints. So the Podman HPC builds are done right in front of you. And by this, I mean like you will see it will run each line of your container file and you will see, you'll see what it's doing. It's really like actually very nice to see. Um, and generally it is easier being able to use Podman HPC is very nice because you can build it. You can immediately go and run it you can run it for a job. And so this is a pretty fast cycle. But like I said before, if you want to use Shifter, you will have to push it to a registry and then pull it back to Perlmutter. So you'll have this like build, store, run sort of cycle. It's fine if you like to do that, if you like Shifter, totally doable, but it is a little simpler if you just use Podman HPC for everything. Um, and like I said before, it is important to migrate if you do want to actually run in the jobs. But if you're just doing a bunch of like testing on the login nodes, like get your container working properly, you don't need to keep migrating. Only do that once you're ready to actually use it in a job. And the builds are cached locally. So if you're on one login node and you're making changes, rebuilding, testing just on the login nodes, the rebuilds should be very fast because all of the steps that happen before the point at which you make a change, like it'll just be able to use all of the cached previous work. But if you were to log out, or maybe your internet connection breaks or something, if you log back in and you log into a different login node, you won't have that cache available. So you can try to remember which login node you're on if something like that happens. It's not a huge deal, but sometimes these can take a while to build. So just something to keep in mind. Um, Yeah, so like I said, the container builds are done task by task, and you'll get to see on the screen, or if you like pipe the output to a log file, you get to see in the log file what is happening, what's completed, and where the errors have occurred. So this is an example of something that will be like printed into your terminal, say step 4/5. You see the like run command. It's very nice and easy to read. Um, and if you have some sort of error that occurs, like I was saying before, it's useful to combine multiple commands into this run with a double ampersand, but actually having them on separate lines, you can then like go into that, comment out everything else, and go and investigate any problems that you might have when you're building. Um, and so yeah, to do this, what you can do is just comment out everything else, and you can actually build the container just up to the point at which there is a failure, and then you can go run in interactive mode, figure out what the correct command would be inside the container, and then go back and fix it. And note here, interactive mode, in this case, interactive mode, entering a container in interactive mode is not the same as running an interactive job, like doing an salloc to run on one of the compute nodes is the same word, but it's different terminology. Um, so one of the most common problems that you would have when you're trying to be able to build your own containers is finding the libraries. So if you had that bash script that works on bare metal, Perlmutter, and you can And like either the libraries are already installed or you can find them on Perlmutter. They're actually going to be in different locations in your container. Um, and in Perlmutter, we have the nice module system that will be able to find you, the versions that and load in the versions that you need. And instead, you're going to need to be able to, you might have problems when you try to do the same thing inside of your container. Um, so what you can do, like I said, is start your container interactively. Um, and to do this, we use the dash IT flag. Um, and again, here we're trying to be responsible and clean up the container so we don't use up too much space on the machine. Um, But here we're running the container in interactive mode. This container is called Hi from inside, and we need to also specify the shell that we want to use when we enter into the container. And it's important that the shell must actually be installed in the container. So if you have some special shell that you like to use, you that isn't going to exist in whatever your container that you've built so far, you're going to need to add that. Um, and then once you're inside of the container running interactively, you can then use find or locate so you can find like where this library you're looking for is. And then you can try all of the rest of the build commands, the thing that failed, from inside of the container until you can find the right command. And then you'll be able to exit the container and then update your container file and try to build again, and hopefully it will work. Um, Something to be aware of is that your bash history is not going to be saved on Perlmutter. You won't just be able to, up arrow back to the last command because it's a separate environment. So you'll need to make sure that you copy and paste so you can keep that correct command that you found. Um, what you probably want to do is actually, as you find something that works, have your container file open in another terminal, um, and then change it as you're finding what works. That's what I would recommend. And then something pretty important for a lot of our users is to be able to use MPI with your containers. Um, so for HPC systems, generally to actually get the most performant MPI, you're going to want the vendor optimized libraries. Uh, and that might not necessarily be what would come with whatever your base image that you've loaded is. Um, so to get the thing is the MPI will probably run, but it probably will not run, or there's no guarantee that it will run well because currently, API compliance is good, so yeah, it means it will run. But ABI compatibility is not exactly great at the moment. So um, what you will want to do for us is on Perlmutter is you'll want to use mpitch, which um, which will most closely match what were our vendor optimized library for Cray mpitch. Um, and you'll want to pick the version of mpitch that's going to best suit whatever your use case is. So if you're using Python, MPI for Py, generally version 3.4 of mpitch is the best, and then sometimes depending on like what, C, C++ code or Fortran code you might be running, you might use 3.4 or 4.2, but you can choose the version. But I think that this is also something that Adam mentioned before. This dash dash MPI flag was something from session one. But if you're using Podman HPC, you'll just want to add this dash dash MPI flag. With Shifter, the command is dash dash module mpitch. Um, and yeah, I think that's yes. So now we have another few exercises that we can do to practice um, with building our own container files. Um, this practice exercise is to build and run a hello world using MPI. So you will probably want to start with this image that is linked here, which no, just let me click on it. It's another Docker Hub container that Adam made that is in Impitch Ubuntu. You'll once again, in order to pull that, you'll want to do the Docker IO slash AW Lively and Pitch Ubuntu. So you can pull that down. Or the actual code for that container is here in this Google Doc. So this will be something that'd be nice, for you to check out, or you can also try to build this yourself. It will take a while. You may not have time actually even to let that build command finish for this exercise. So I would recommend pulling this container and then maybe also trying to build it, see if you have time for that, to actually run. And then for the MPI Hello World, there's this repo here um, that you can use that has basically it's a GitHub repo that has an MPI Hello World and some more instructions in the README. But yeah, so I would recommend that you try to run it on a login node and then make sure migrate it to Scratch. And then try running it as an interactive job, and then also see if you can run it on a batch job if and use two nodes so you can test the MPI. Uh, and then as a bonus, if you want to practice using Shifter, we have some bonus exercises for that. Um, so to give people time to do this, I guess come back at 10:45 to, well, I'll come back and run through the exercise at 10:45, and we'll be available in the Q&A to answer any questions, help troubleshoot any issues that you're having until then. So, yeah, talk to you again at 10:45. Okay, so um, here I will kind of talk through, like run through how to do these exercises. Um, so to build the container file that we want, like I said, we have this container file to start from. Oh boy. Uh, so there's probably some extra stuff in this that we wouldn't necessarily 100% need to be able to run this OpenMPI Hello World, but we're starting from, once again, this Ubuntu 22.04. Here, we're setting environment variables. We're installing a bunch of things that we don't necessarily need, but it's kind of a good baseline of things that you might in general want inside of a container. Um, this run command is sort of just cleaning up some space so the container isn't as large, like Adam was saying. They can be like really, really big. So this is just sort of trying to keep the image size under control, I guess. Um, And here we're using this arg to be able to quickly change between different in pitch versions if we want to, um, depending on like what sort of application we might be using. Um, and so yeah, um, so we have that as like as the base container. And what I have already done here is, well, let's see what else did I have with that. Yeah, I have a container file. Um, and so in this container file, I'm using that base image from Adam's version that he uploaded to Docker Hub. Um, and then, we also just pull down this Git repository that I've pointed to before from the example. And then we compile and run the hello world. So let's see if we can actually build this. I mean, it should work. See. image hello world. Oh. And I am in the directory with the container file called container file. So I use this dot instead of the dash F option. And now you can see like it's going to go through step by step um, and do the build. Here it has to actually pull that container file down from Docker Hub. I had not yet run it on this login node because I did log out and log back in, and it put me on a different login node. But this doesn't take a super long time to build, so that's okay. And then we can, but it would have been faster if I had already had it cached. Um, and then we can run it. And here we are again, like cleaning it up after we run it so that we can save space. And we're going to run the hello.out inside. We're going to use the hello.out command to run that executable that we created inside of our container. Yeah. And so you see this is running on the login node. It's just got, we only have one node, so there's only one rank. It does run on the one MPI task that it has. And then to run on the login node, we need to migrate it. So this will just move it over into Scratch so that we can access it there. Okay. And then second part. This technically we should be probably using the allocation or command to do that. So we'll see how fast this goes. Hopefully. Okay, cool. And now we can do the srun. So now we're interactively on one of the compute nodes. We can run the container here. And we're using the dash dash MPI flag to get the best, to say we want to use MPI with this, because we do. And this should run actually onto, okay, so now we see we get two tasks because we're on two nodes. And then we can leave our interactive allocation. And then I have a bash script for the MPI hello world, which is as we've shown right here. Um, Basically just running the same srun command, but we'll be able to launch this as a batch script instead of running everything, actually getting an interactive allocation. So batch. And then it will run eventually. I don't know how long it's going to take for me to get through the queue, but it will run and it will print out the result into that .out file. Eventually. Probably runs faster if you're actually using the allocation we have for this training. But it should just print out the exact same thing that we got running interactively. Um, I won't make us wait for it, but hopefully this is working for everybody. And yeah, Adam will do the next part, section 3.